Hello everyone, my name is Yu Mingrui. It's a great honor for me to present our work, a Coarse-to-Fine framework for dual-arm manipulation of deformable linear objects with whole-body obstacle avoidance. We focus on a general problem, dual-arm manipulating a DLO from a start configuration to a goal configuration. In our previous work, we have well achieved adaptive large deformation control of DLOs. Then, how about more practical scenarios? In real applications, obstacles and robot arm bodies must be considered. In such tasks, global planning is necessary. However, planning is more affected by the inevitable DLO model errors than control. Let's think about how humans achieve this task. I guess we will first imagine a DLO body path. Then, you will try to move it approximately along the path while watching it and adjusting hand movements. Inspired by such processes, we propose an approach which combines both global planning and local control. The planner first plans a coarse path to efficiently find a global feasible solution. Then, the planned path is sent to the controller as guidance. The controller tracks this path and reacts to real-time feedback to improve the robustness and accuracy. First, we design 3 tasks to test the overall performance. From the table, we can see that the planning success rate is high and the time cost is just several seconds. The closed-loop manipulation is robust and the final task errors are very small. In the real-world experiments, we design 3 tasks and test 3 different DLOs. In task 1, the DLO needs to be rotated around 180 degrees. In task 2, the DLO's bended body must be considered for avoiding clearance. In task 3, the DLO needs to be manipulated from an upper semicircle shape to a lower semicircle shape. Thank you for your listening.